Hey guys, today we will talk about trunk-based development and how we used it in one of our projects. So let's start with structure of the presentation. I will start with introduction. We will cover what is trunk-based development, our approach on our project, adaptation of TBD, like with custom stuff, and challenges we faced along with the benefits we received. So chapter one, once upon a time in Git Flow occupied project. So we have the playbook with all the processes described for our project. And basically our general rules for working on tickets are modified Git Flow / GitHub Flow approach. So we creating basically one branch per ticket, not including big PRs. Sometimes it require few parts, but in general, we have like one branch per ticket. We need to plan our work ahead but splitting subtasks only in task tracker. In our case, it's Jira. So we also could split our work by commits, but overall, the general rule is like one big PR. And for those of you who don't know what Git Flow is Git Flow is when you like have 5 branches for different purposes. You have release branch, which you create from develop branch before the release and before merging to master. You have master, which going to be deployed to production. You have develop branch for like development and merging features, and you creating feature branches. But we don't use all of the 5 branches. We basically using 3 of them on our project because we merging our feature branches directly into the main branch, because we have a small team, so it's not a problem to block main for merging for release time. So it works, but sometimes there are a lot of big pull requests with like not big PPR, sometimes like giant, and it works, but sometimes PRs like waiting for review like really long time. It may take like for a week or sometimes for a month for big PRs to get reviewed. And one day we received a new requirement from the client. We need to make everyday releases to deliver features as quickly as possible, but we still need to somehow deliver the big features. How we could do that? Because sometimes main locked for testing. For example, we just merged big feature. I mean, we didn't test it yet, and to deploy it on staging, we need to merge it to main. So, and imagine we need to deliver something small quickly. How we could do that? Like there is no way to do it with our current approach. And one of the requirements was, as I said, instead of sprint releases once a week, now is to deliver features ASAP daily. So we need to adjust our processes accordingly. And here came the topic of the day. What is trunk-based development? Chapter 2. So in general, here's the definition of trunk you most likely don't need, but in trunk-based development, trunk is just like growing tree where the fattest and longest part of this tree is trunk and not the branches that like came radiate from it. So you need to merge directly into the trunk. What are the key concepts of trunk-based development? There are, I would say, from 3 to 5 key concepts. We will focus on each of them. The first one is commit directly to the main. It may look and sound weird and strange, but overall, it doesn't necessarily mean you need to make git push -f main. It's most likely means that you don't need to have a lot of additional branches to support your code, such as release branch or like develop branch. You creating your feature branches and merging them directly into the main. And the main is just one branch with all the pieces of changes, and the code should always work properly on that main branch, which moves us to the CI/CD. So we need to ensure that our main is always working correctly, our main is green, so we don't break something. And we need to have tests to make it covered somehow. And we also need to have really simple deploy process, so we could quickly deploy even small pieces of changes without like hours of manual work. So ideally, just by clicking one button or even automatically. So I can't help but show you that on our project we have 98% of coverage, but that's not like important. You just need to cover all the important parts that may break, at least with unit and integrational tests. You should have reasonable amount of tests. You should not be focused on like 100% or something like that. I just can't help but show it. Second concept is third concept is branch by abstraction. What does it mean? This is like the main concept of trunk-based development, and this is the way you develop features. And this like concept contains the most different approach parts and stuff. So let's cover it on example. Imagine we have a car and we need to switch the wheels. Instead of just unscrewing old ones and screwing the new ones, we now split in work into some sub steps. Initially, we create abstraction layer over the old wheel, which will like just behave as wrapper to present the current state. Then we develop a new component, in that case, new wheel, and we attach it to this wrapper so we could quickly shift between the old and new implementation. And when we will sure that everything is working correctly, we just applying this approach for all the places when we need to switch the old implementation with the new ones. And when everything is turned on, like we have no places in code where we're using the old implementation, we just removing this wrapper and we have this car with new wheels. And the main point here is that for all of the 5 steps, because we're counting from 0, right? We program it. So in all of the steps, the car could ride without any problems. The car is fully functionable. So which comes next approach is like, I mean, key points is feature flag. In order to switch easily between old implementation and new implementation, we need to build some kind of mechanism. Sometimes it's called feature flag, sometimes it's called feature toggles. But overall, this is just an approach to toggle our code between different states. It's like a condition. If the feature is enabled, use this. If feature is not enabled, use another part of code. For feature flags in Ruby, in Rails, most popular tool called Flipper. There are a lot of different adapters you could use from in order to preserve the state of the features. But for Rails, obviously, the better way is Active Record. So what it does? The use is pretty easy. So on the backend, you just using flipper.enabled, and you, as I said, just using the simple conditions in order to check the features. But you could add additional complexity over it, like enabling features for specific actors, for specific groups, or specific amount of the time, for example. And you could manage and control these features using UI. It also built in, so even clients and stakeholders that are not available to code could toggle features on and off. But sometimes it may be tricky to integrate this well if you have complicated front-end backend structure. For example, we have GraphQL, and we needed to build a custom way to pass these feature flags from backend to front end. So it may be not that simple to make it work just out of the box. So let's call about the benefits of trunk-based development. We install it, we adapted our processes, we're using it. So what benefits it will give us? First of all is continuous integration. Tests should always be green between stages, and this allows us to ensure that our code is working properly, and there is no way to like ignore or avoid this, because in that case it will just not work. Reduced merge conflicts. As we have like small pull requests, branches are merged fast. They are easier to review, changes are atomic and small. You could always see what the purpose of specific commit slash like pull request. And of course, faster feedback loop. We could easily test it because we could adjust small steps incrementally. And the good thing is just be able to do phased rollouts like out of the box also. What I mean about by phased rollouts is when you need to migrate from one structure of database, for example, to another structure, and you need to migrate a lot of data or something like that. Here comes chapter 3, integration. We need to adjust our playbook. We adjusted it, and basically, main changes are instead of creating one branch for every new ticket, we create one or more short-lived feature branches. They should not exist for more than a few days. Ideally, if you will check like the source of truth for trunk-based development official website, you will see that they suggest branches to not exist even more than 1 day, but we have a small team, so we decided to make it a few days. And also, now we're able to split our like subtasks in Jira and attach them to specific pull requests. It's suggested but not required. And also we added an additional step after right before moving the ticket to done is to wrap everything in a feature flag and remove this feature flag when the feature is properly tested and merged. So we have a great success. Everything is working correctly. That's it. Thank you for your attention. Like that's an. You didn't believe me, did you? Because like it's not that good as you might think. The question here, as I said, is it that good? And the answer is like no. Obviously, we face some changes and problems, and let's cover some of them. The main challenges are like these 3 challenges. The first one is complexity and abstraction. Like for the developers who are less familiar with design patterns and ways to split work, ways to design architecture, it might be quite difficult to create abstraction which will work well and create them quickly. And also, there is some like time because learning curve is like not really easy, and it takes some time for the team to understand how to effectively break down features into these small chunks and abstractions without introducing dependencies between the pull requests. And also additional steps with feature flags. As I said, instead of just creating some code and just merging it and testing it, now we need to create this code, wrap it into the feature flag, then test it, and then remove the feature flag. So it's basically 2 additional steps. So, okay, it's like challenging, but it potentially could be fixed during the time. And now we have everything working. And even though everything has been covered, now we need to review 10 PRs instead of 1. So yeah, they are small, but still we have like 10 PRs. And sometimes the code review still might be slow, no matter what, but at least we merging everything incrementally, and we don't need to rebase this branch like every day while this PR is opened. Chapter 4, operation stack. As I said, it's not always simple to merge code because it cannot be reviewed quickly sometimes, and it brings us to stacking workflow. Because when the code review is slow and during trunk-based development you want to deliver everything fast, sometimes it's impossible to create branches that could be merged without like the parent branches. So it sometimes, not always, but sometimes it contains related changes. Here comes the stacking workflow. What it is just a way of merging in which you, instead of merging every pull request into the main and then creating the second and third and so on parts from the main, you use your previous pull request as parent for like for next pull request in a row. There are a lot of different ways of managing these stack PRs, but honestly, they all kind of sucks. I mean, default methods. Even Git has update refs flag, which will update all the parents. If you will rebase, for example, main into the first pull request, it will update sequentially all other PRs. But it is not convenient. But there are a few tools that might simplify work for you. For example, one of the tools is Graphite CLI. You just doing simple CLI commands like git stack, git update, or something like that, and it will automatically update all the PRs, even adjusted. I mean, Graphite even could add some comments to these PRs with direct links between all the PRs to show where you are, what the reason of this PR, and how it connected between other PRs. It's suggested but not required. But as I said, I tried it, and yeah, it might work in some cases. And we have the last chapter, chapter 5, Revenge of the Giant PR. And here, after we used this trunk-based development technique for a while, I counted, and it was 140 days of using trunk-based development. We got new updated requirements, and now we don't need to make releases every day, or like at least it would be good, but not required to make releases every day. And we changed our processes from Kanban and daily releases back to sprints. Now we have Jira sprints again. We have like 2 weeks of work, and we decided that we could return our previous processes because sometimes like it's still faster to create one big PR and get it reviewed instead of like multiple small PRs. For example, for the bug fixes or something like that, sometimes you just need to fix a bug instead of just toggling these feature flags and checking and merging. So it adds some mental overhead, as I said. And if the requirements for the ticket is not clear, it's sometimes not that obvious how you could split the ticket and the work between multiple PRs. So you just start building something and it grows. We changed our playbook again. We reverted our old rules with some additions. So right now we again have one branch for every new ticket that we're working on, with some exceptions. And here we have new point that we need to be reasonable with the size of the branch. If the branch is too big, we decided to like estimate approximate review time, and if it's bigger than 30 minutes, let's split it. And we also add some suggestions for handling multi-part tickets, like how to check, do you need to split your pull request or not, and which questions you could ask yourself to do it. So right now it's not Git flow. Right now it's not actually full 100% trunk-based development. You could call it integrated trunk-based development. We don't call it somehow. So we're using our main branch anyway. So we don't have development branch, and our process matches almost all of the TBD rules easily. But right now, it's up to developer and up to specific case to choose either you want to create one pull request or you want to split it on smaller parts. Right now, it's not required, so it could be really easy. Let it be that way. In conclusion, I want to say that the overall experience has been positive. We learned a lot. We adapted our processes, and now they are better. There are still few things unresolved, but they are not that painful to spend a lot of time for resolving them. Trunk-based development is not a silver bullet. You need to think carefully before you want to try it. But I think at least once you need to try it just to understand what positive things it could bring to your project. If you are open for experiments, feel free to do that. It may not be the best fit for smaller teams, although on the website it states that you could adjust it for small and big teams with like some different methods. Still, if your reviews and your dev team, for example, of three persons reviewing not so fast, it may not be the best fit because it will require you to do those stack pull requests and so on. And I already said that, but it can be particularly challenging for the teams with less dev experience. And sometimes you see that you could split it by, for example, other ways and other abstractions, but you see this after you already created 5 PRs and you're like, well, okay, we need to bring interdependencies here. And effective implementation relies on robust CI/CD. That already has been mentioned, but I think it's a plus because it requires you to set up this. But if you don't have CI/CD, you can't efficiently use trunk-based development. And it enables more rapid delivery of features and updates. So even something is not working properly, you could just switch the feature off, and you even don't need to do another deploy or rollback or something like that. So that's basically it. Thank you, guys. And if you have any questions, feel free to ask. Thank you. Yes, Eugene. I don't see everyone, so you could just ask your questions without raising a hand.
Usually we can't hear you, just in case you're trying to ask a question.
Well, that's an interesting question. Actually, I need to think about it more.
Okay. Okay, let me take over and kick it off with the first question. I was curious, so is it correct that every feature starts with a feature flag? Like if you begin the development of some feature, it starts from a new
Yeah,
feature flag.
like I would say 90% of them. Sometimes you create a feature flag on front end, so you just change the logic, but you don't let the final customers, final users see the result of your changes by just disabling them on the UI. Sometimes it requires you to just change backend rules and yeah, wrap everything into feature flag. But yeah, for most of the cases, feature flag is required.
Okay, and how do you know it should be a new feature flag, or should you rather use some existing feature flag? I mean, if like another developer from your team is working on the same domain or something like this.
These feature flags are really atomic, so there was no single case where you think like, or should I use the existing one or create a new one? You just create a new one and don't care
Okay.
because it will be removed like in a week. So
Okay. And one more question, how do you handle the security side of this? Because if you need to exchange feature flags between backend and front end, sometimes you want to hide some private information or sensitive information from front end part. And when you share feature flags, you can basically cause some informational leak or something like this. So yeah, so the broader question, how do you handle security stuff?
yeah, this is an interesting question which will require, and to completely describe it, which will require to use another hour of our time. But in brief, we had like a few stages of establishing feature flags. Initially, we just created one simple endpoint, not connected with GraphQL and not secured by any authentication authorization, which will just return in all the feature flags because this feature flags was not different between different companies. They was global, so we just don't care about any leaks because like this is the name of the feature, like nothing can happen. But later we improved this, and we using relay and GraphQL, as I said, and in order to more deeply integrate it and use it more conveniently. For example, to check with TypeScript on front end the specific feature flags and all that stuff, we adjusted it. And actually, I don't really remember at what stage we are right now. We either have the opened infrastructure ticket to wrap endpoint with authorization authentication, or we already implemented it. I don't really know. Maybe Elvin could help me.
No, all endpoints for feature flags are unauthorized because we use feature flags on this, places where there's no authorization. Like,
Yeah.
for example, like authorization pages. So,
and we do have such tickets for some feature flags, which may be company or user specifics, but this is more not about the trunk-based development or feature flag itself. We created this ticket for making feature flags usable for A/B testing and something like that, in order to enable company-wise features. But for now, we don't need it.
Okay, I got it. Thank you, and I will pass it to Eugene because I see that he already wrote something.
Have any specialties to handle feature flags on front end? Do you manage single place someone with API part? How do you manage bundle part? Not deliver extra code when it's not used. We it's kind of complicated system, but we using right now we fetching feature flags for each page specifically, and we checking Boolean values of specific feature flags. For example, if we have page, we use Next.js. On the Next.js page, we directly specify the feature flags we need to request for the backend, and we requesting them specifically.
Okay, I can hear silence. Oh, Eugene just texted something.
I can
Yeah,
answer
in runtime.
if you want.
Yep.
So basically, we try to fetch it during server-side rendering. So when user opens the page, all available feature flags are already loaded. But code-wise, we load all code related to all features in progress. So it's not like some module will be loaded only if feature flag is enabled. All the code for frontend is loaded as well.
Initially, I created a page in Confluence for like listing all the feature flags and describing them. But this was like the shittiest idea ever, because we just had +1 place which will not be updated. So right now we just when you remove some feature flag on backend, for example, if you remove it, sorry, not backend, front end, TypeScript will highlight all the places where you need to clean this feature flag, and that's basically the main part of the process. So you just remove it in one place, and we have like enum with all the features available. You remove it there, and it will show all the places where it's used. And then you could track the backend parts of the code, or just by grabbing them by feature flag name.
Okay.
I already received like 3 likes from Eugene. That's great.
That's great. I just have one more question. So from the presentation, we learned how to navigate between old code and new code when it comes to the daily releases. But how do you deal with data when you need to I don't know, amend the database structure somehow, some way. Because like in real development, you like from time to time, you really need to run some data migrations. And I'm not even speaking about data structure migrations. I literally mean data migration when you need to change something over data. And yeah, it makes me wondering how to make this possible in this like daily releases process and rank-based development.
Well, here the answer, as usual, is depends. So it depends on use cases and the data. Recently, we finished the like large and big migration from database. We needed to migrate our like user credentials into the AWS Secret Manager. So in that case, we just did it incrementally by adding feature flags and toggles for legacy integrations and new ones. Sometimes it may be resolved by creating rake tasks and applying them. So I cannot answer specifically because this is like really context based.
Yeah, I understand, but it doesn't cover like my interest because you see, for example, we have some data which is used by two different places of code, and now we need to change this data. For example, because of like data corruption, let's say, when we were writing wrong data to the database and now we need to change it. And we can do this only like we can basically, so we can't prolong it. We can only, I don't know, do this by one time. Okay, maybe I'm just going too deep.
I just don't don't understand how it's related to the trunk-based development, because what you're talking here is like covers just data migration overall and like validations and stuff.
Yeah, because when you don't have this constraint of daily releases, you can give it some time. You can give it some time to figure out all the data relations and so on, and you can give it some time to amend both data and both code, like, and release it within one pull request. You can, but when you deal with trunk-based development, as I understand, it's supposed to be daily releases or close to daily releases, and you don't have such an opportunity to figure this out because of basically time constraints.
Well, daily releases requirement came mostly not from trunk-based development, but from the client. So we could potentially slow down and describe like the purpose. So, for example, we have like corrupted data and so on, so on. Trunk-based development doesn't require you to deploy everything daily, or I don't know. It's just about having the code in a like acceptable and working state all the time, not the data itself. It's mostly about the code. And for the data, as I said, it's about the usual data migration. You're just trying to do everything revertible if it's possible. Sometimes you apply database. I forgot this word. Oh my god. Denormalization, for example, or storing something in two places just for a few days or a few pull requests, sometimes something like that.
Okay. Yeah, it makes sense. Thank you very much.